Good afternoon. A little bit later today, getting into this than I normally am, so sorry these are going to be posted a little bit later than normal, but it happens. I had a meeting earlier. All right, so last time we were starting to talk about we had talked about atoms, right? And we had said that an atom, a very simplistic view of an atom, can an atom can be described as consisting of three particles. And we had talked about how in the nucleus we have protons and neutrons, and the number of protons is what determined what an atom was. And then the number of protons also determined the number of electrons that were orbiting around the nucleus. And we had said that you have an equal number of electrons and protons, and we had said protons are positively charged and electrons are negatively charged, and that electrons carry different levels of energy. And so depending on how much energy they have, they're attracted to the proton, and so they orbit a certain distance from the proton. The more energy they have, the further away they are from the nucleus. And we had said that in some cases, an atom can give away an electron to somebody else in order to fill an electron shell. And remember, we had said that there can only be a certain number of electrons in any of these orbits. And we had said the orbit is determined by the amount of energy carried by the electron. And what happens is an atom gains stability, and as a result of that, we say it wants, but it really has to do with the stability of the atom. The atom wants to have a filled outer electron shell. And if you have, and the electron shells, in most cases, all but the innermost shell, will be filled with 8 electrons. So if you have only one in your outer shell, one of the things you can do is give it to another atom. And who would want it? What other atom would want your spare electron? An atom that has 7, right? So we had said atoms want to have these filled outer electron shells. And as a result of that, in some cases, one atom will give an electron to another atom. But what happens is we had said we started out in every one of these atoms with having the same number of protons and electrons, the exact same number of positives as negatives. And so if you have 3 protons and 3 electrons, your charge is balanced, right? There's 1 negative for every positive. But if you are this atom that has the 3 and you gave away 1, because remember I said the innermost shell only has 2, so it's probably not a good choice, but I was throwing around the example of lithium. So in order for lithium that has 3 protons and 3 electrons to get rid of the 1 that's in its outer shell, it can give it to somebody that has 7 in its outer shell. And the typical atom that it gives it to is chlorine. And so it would make lithium positive because it'd have 3 protons and 2 electrons. And then the one that received it would have 1 extra electron. And so it would be negative, right? And so we had said, what does this produce? This produces a cation is a positive ion, and an anion is a negative ion. And what would happen? So you have this negative or positively charged lithium and negatively charged chloride. Well, positives and negatives attract, and so those 2 atoms come together, in what we would call, it's a form of bonding. It's called ionic bonding, and they stick together. And this is the kind of ways that atoms can stick together when you're producing something like a salt. And that's what we call ionic bonding. And now, so if you're at the extremes where I said you have one outer shell electron or 7 outer shell electrons, it makes sense to either give away an electron or to receive an electron. But if you're something like carbon that has 4 outer shell electrons, that means you would either have to give away 4 or receive 4, and that doesn't happen. So there's another way that atoms can achieve stability, that business of having a filled outer electron shell. And what happens is they can share pairs of electrons. So with carbon, it can share a pair of electrons with 4 other atoms. And if it does that, it gains this stability that I'm talking about. And this is going to be what we call covalent bonding. So we have covalent bonding is sharing pairs of electrons, and ionic bonding is where one atom gives an electron away and another receives it. In both cases, it achieves stability, and this is what drives these two processes, basically, are what drive what we call chemical reactions, trying to achieve stability. So that's how we do this. So I'm not in this class going to go into a real complicated explanation of this. In other classes I do, but this one we just sort of talk about how atoms come together. And if you think about later on, we're going to talk about how you can produce really huge molecules, huge groups of atoms by combining one carbon with another. The fact that it can combine with 4 other atoms means that it can make giant molecules. And we'll talk about that here in a few minutes. But for now, one of the things that can happen is if we think of water, and water is H2O, hydrogen, 2 hydrogens are sharing pairs of electrons with 1 oxygen. H2 means 2 hydrogen, O means 1. So, means we only say O, we don't say O1. You say H2O, and implied in that is that there's 1 oxygen. H2 means 2 hydrogens, and just saying the O means 1 oxygen. And so what can happen, there's this really weird phenomenon where a hydrogen, if we were to look at the periodic table, and we'll be able to do that on Tuesday when we are sitting in class. You're going to be sitting in class on Tuesday in the lab at 9:30 in the morning. Just a reminder. When we're looking at the periodic table, you can see there's a list of all of these elements, and you can see if you find hydrogen, you see it shows 1. And I said that the subatomic particle called a proton determines the identity of an atom. And I said, if you have 1, so when we talk about hydrogen, it's the very first, the simplest element there is. All it has is 1 proton. And we'd said, what determines the number of electrons is the number of protons. So if you say 1 proton, 1 electron, that's it. It's very simple. Now, and so you have 2 of these hydrogens that are going to share pairs of electrons with oxygen. Well, it ends up sometimes that H2O will break apart into an H with no electron and the OH with an extra electron. And so that proton, that H, if we'd said all that a hydrogen consists of is a proton and an electron, and that darn OH stole the electron. So that means the hydrogen is just a proton. That's all. That's all it is. Now, that thing, it's not going to take it lying down. It's not going to take the loss of its electron lying down, as the saying goes, right? So what does that mean? That means that it's going to try and grab an electron from somebody. It wants an electron. And I'd said, that means it's unstable. I said, bonding produces stable conditions. Well, it ends up that the presence of those darn hydrogens without an electron, we call those protons. Well, the concentration of those, the higher the concentration, the more acidic a solution is. So what is an acid? An acid is a solution that contains extra hydrogen ions. And when we say a hydrogen ion, it's a positively charged ion. It's a cation, and it's reactive. So everyone knows if you get acid on you, you better get it off. Why? Because it's trying to get your electrons. And so the more of these hydrogen ions that are present in a solution, the more acidic the solution is. And if every hydrogen that's in the liquid is ionized, meaning it doesn't have its electron, if every single one is, that is going to be what we call the super most acid you can get, right? And we're going to say it's pH of 0. Now, as you move up, you have 10 times less. So we have an inverse relationship. I'm talking about the pH scale. And the pH scale goes from 0, a superacid, all the way up to 14. And 14 has very, very few of those hydrogen ions. Now, so from 0 to, so if we think about pH, you say, all right, I know you got the acid on one end, and you got the alkaline, also known as the base, on the other end. What's in the middle? Neutral. Neutral is in the middle. And what does that mean? What is neutral? What it means is just in regular garden variety water, pure water, in regular water, it has to do with how often that molecule breaks apart and produces a hydrogen ion. And it does it very rarely. It does it 1 every 10 million molecules. And so we have this pH scale that says that when the concentration is 1 in every 10 million molecules, it's going to be a pH of 7. It's a logarithmic scale. So if it's 1 in 10, so if we said 0 is perfect, it is pure acid. If we said you have 10% hydrogen ions, that will be a pH of 1. And if we had said 1%, 1 in 100, so 1 in 10 is a pH of 1, 1 in 100 is a pH of 2, 1 in 1,000 is a pH of 3, 1 in 10,000 is a pH of 4, 1 in 100,000 is a pH of 5, 1 in 1,000,000 is a pH of 6, and 1 in 10 million is a pH of 7. So if you keep on going to 14, you go pH of 8, that means that it's 1 out of every 100 million. pH of 9 is 1 out of every billion, and so on until you get to 14. I've never counted that high. So anyway, we have a pH scale, and all it is a measure of the concentration of hydrogen ions in a solution. And you can look, my printer didn't print it very well, did it? But anyway, you have a much better picture in your slides, so use your slides and not mine to look at some examples of different pHs, solutions with different kinds of pHs. All right, I'm gonna stop here. We've gone 15 minutes. Oh my, that's too much. It'll take forever to upload. Oh well. We're gonna come back and talk about organic molecules. Molecules made of carbon. All right, be right back.